This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett. In today's episode, we're going to talk about a lightning storm igniting some natural gas from a leak offshore near Mexico, New Jersey versus Maine, some of the different legislation that's going on over there as far as use of offshore assets, federal versus state waters. Maine's put in a big ban on using offshore wind in state waters, so we'll chat through that. Turbine validation at the Galloper wind farm offshore, and then beyond wind to hydrogen project that's getting a little bit of steam. We'll talk about this unique PowerPod wind turbine, which is a 1 kilowatt prototype for residential use. And also we'll talk a little bit about offshore wind, some of the engineering challenges, and how ocean cleanup might have a relatable story to some of this unproven technology. Before we get going, let me remind you, you can easily sign up for Uptime Tech News, which is just our weekly newsletter, in the description or show notes of this podcast. And that's just getting a weekly update from us as, hey, here's our latest podcast, check it out. Here's some other news from around the web. So if you're interested in staying up to date, definitely check out Uptime Tech News in the show notes below. So Alan, how you doing, sir? Let's talk about lightning, your favorite thing. This lightning storm out in the waters near Mexico looks like it ignited some natural gas leak from a pipe, well below the surface.
So there's a big gas explosion in the Gulf of Mexico next to an oil rig, and one of the byproducts of oil drilling is you get natural gas in those same spots, right? So they had a lightning storm come through and ignite that gas, and it looks like this a big apocalyptic fire in the middle of the ocean. Like, wow, there's water. Wow, there's fire. Those two don't go together. There must be something wrong with the earth or wrong with humans' involvement with the earth that caused this big thing to happen. No, none of that was true. And the Twitter bouncing around from environmentalist groups, so to speak, and business groups on the other side, or pro-drilling groups on the other side, which is ridiculous on both ends a little bit. The fire was put out within a couple of hours, and they had a handle on how to go do that, it sounds like, because they got it out. But does it benefit green energy? No, we still need to be drilling in the Gulf of Mexico for now. Does it benefit the sort of the oil drilling community? No, because you had an accident, right? So anytime there's an accident, it just gets blown up worldwide. I mean, that image I saw from Twitter from all across the world. So, neither side is right. I think from the lightning protection side, you want to look at what happened. And the post-mortem on this is going to be really, really interesting to see what caused that to happen. What was the chain of events that caused that to happen, and how do you prevent that in the future? Obviously, they had a plan of attack of how to go shut it off, and that was the right thing to do. But you want to prevent that from occurring in the first place, because fire in any oil drilling situation, or uncontrolled fire, is a problem, and it creates a huge safety risk for everybody that's on that oil rig. So I think the takeout from this is that, hey, we need to go look at what the root causes were and to disseminate the solution to everybody in the Gulf of Mexico. Like, this is what we're going to do to prevent this from happening in the future. And from the engineering side, I think that's the ultimate benefit out of it. So luckily, no one really got seriously hurt in this event, but it does raise some red flags like, hey, we need to really be careful because we're dealing with explosive materials, and there's a lot of lightning storms in the Gulf of Mexico. So
All right. So moving on, some interesting sort of conflicting state laws. So I think it's really interesting to see the difference between what California is doing versus what Maine's doing. And obviously, we understand the reason, and Maine's not really an opponent of offshore wind. They're just trying to find a better balance of protecting their fishermen. So in California, the state Senate committee has approved a bill to set a goal for offshore production, and they're trying to make this into law so they can just continue to set these standards that we're going to keep moving towards creating more jobs and get more offshore wind set up. Whereas over in Maine, they've prohibited offshore wind farms in state waters, which that's the first 3 miles offshore, after which it becomes federal water. So just a stark difference. And again, like Governor Janet Mills she's not an opponent of wind. She's a outspoken supporter of wind energy, but she's just trying to find a compromise with fishermen who are, like we've talked about last week, rightly concerned about their livelihood and continuing to deliver on, Maine is thought of, when you think Maine, you think lobster, right? Or, Vermont blueberries, all that stuff. So it seems like she's found a balance, but obviously in the headlines, depending on what, media outlet might be reporting this, it could look a lot of different ways. But again, it doesn't seem like there's a real any sort of like malintent, just that's their compromise. Alan, what's your take on the situation and some of the differences between these states and the way they're going to start to regulate and push offshore wind forward?
I think there's a unique difference between the East Coast of the United States and the West Coast of the United States in regards to offshore wind. And it has to do with what we term the continental shelf. Where does the continent sort of fall off and get into really deep waters? And on the East Coast of the United States, there is this extended, relatively shallow portion of the seabed that extends out quite far, versus California, which it pretty much gets to deep water immediately. So the type of wind turbine you're going to use is greatly different. And I think if you look at the percentage of power that could be created on the East Coast and the West Coast, it's essentially 50-50 in terms of the raw numbers, in terms of what you could produce, or 60-40. I think maybe 60% California, 40% on the East Coast. So on the East Coast, if you shove the wind turbine community 3+ miles out, which is what's going to happen, and pretty much anywhere up and down the coast, I think, you're still not that deep. You're not so deep that you're going to necessarily go to a floating turbine concept. You may, in some places, have to do that, but I think they're still going to be anchored. I think some of them will be anchored because they'll still be close enough to go do that, just like some of the offshore wind that already exists. On California, you're pretty much talking about floating, just because of the nature of the continental shelf. So, in Maine, if you say, hey, we want to shove you 3 miles out, that just means you got 3 miles more to travel to install these turbines, and you got 3 miles more cable. But otherwise, probably not too much change in the type of turbine you were going to install. If you do that in California, much bigger deal. And California has really pushed anything, like I think they had suspended all oil drilling off the coast of California. I think that happened. So one of the reasons why, and at the time, was the visual. Like, we want to go to the ocean. We want to go to the beach. We don't want to see an oil rig out in the distance. Well, I think that same thing is going to exist when it comes to wind, when it comes down to it. So you're talking about really floating wind off the coast of California, and some anchored, maybe some floating off the East Coast. So Maine, it may be the first one to do that, but they won't be the last, in my opinion. I think Massachusetts will, if it hasn't done it already, will do it. New Jersey will do it. Delaware will do it, because the consequences aren't that much financially on the installation, and the politics of it will force them to do that, because who owns a house on the ocean? It's not your poorest in your community. It's the wealthiest in your community, typically, in the United States. So there's some political pull there.
I find it interesting in general to see almost the different personalities, if you call it that, of the states. Yeah. And California is such a mess in just like what's going on. And this is not a political statement, but it's just when you think of all the big issues, and yet the things that California sort of has led the way on, like California leads the way on, banning unhealthy things, which also regulates people's lives a little more, which some people don't obviously want. Or, renewable energy, like tons of it. California is all for it. Yet again, California has a really huge homeless problem. They also have a huge environmental problem with drought and with fires. So it's weird that you'd think that they're doing all these sort of quote unquote right things for the environment, which it seems like they are. California is not afraid to, make changes for environment's sake. But then they're not, it's just such a complex climate out there. There's so much money, just the way things are developed. It's just interesting how they're like seemingly doing the right things and yet still have a lot of problems that they're trying to solve that other states don't. It's just interesting that all of them have it's just complicated, trying to make life grand for all, but it's not that easy.
Well, Dan, let me throw this out because there's been some chatter about the drought situation in California. There has been more recent discussions because of the fire that it is about to happen and will inevitably happen in California this year because it's just such drought conditions. It's crazy dry in California right now. Using offshore wind or nuclear, for that matter, to desalinate and to create more water for California so they can maybe address some of the dryness issues and putting out the fire issues, but also, that they're talking about restricting water by 15%. I think the governor came out this past week and said we need to cut water usage by 15% across the state. Well, that's a huge problem. And as people exit the state, which is what's happening now, California's going to, won't you see, they're going to run into a real economic model problem where their tax revenue into them is going to decrease, and it's just this bad cyclical way down this economic struggle, which will be as companies leave because of lack of water and all these other reasons and fires. That the state's
companies love water, hate fires.
Yeah,
just like the lightning strike.
Yeah, right.
Yeah. Big, the checklist. Yeah, my company, fewer fires, more water, please.
Right.
Yeah.
And they're getting the opposite right now. They're getting less water and less water and more fires. And even though there doesn't seem to be a real plan to attack the fires, I'd say there isn't one, but it's not well publicized, and the water situation is nuts because they're basically importing a lot of the water from adjacent states via the huge aqueducts. But it all comes back to energy creation. It just does. And then the way to solve those problems is with energy creation. And how fast are they going to bring on offshore wind and the likelihood of nuclear to help solve the issues that they have? That's a real question right now. And I like you said, there are a lot of struggles going on inside of California with all the other problems they're having. Can they navigate and manage them simultaneously? I'm not sure that they can. Which is where the struggle will be. And it is, California is a huge economic power in the world by itself. Maybe it's like the 7th largest economic producer in the world. So that's a problem not only for the United States, it's a problem for the world. You need California to be functioning economically, and power is one way that it does that.
Well, and I don't want to go down a rabbit hole with desalination, but it's funny you bring that up. I was down a YouTube rabbit hole about that many months ago. Just, it's one of those like, why don't we just desalinate water for places that don't have it, like in the Middle East where they, have, drought conditions all the time. And desalination is really hard, like as a problem, because there's various different ways to do it, many of which are way too expensive. And I believe the cheapest way, and I could be misquoting myself here, still has to pump brine back into the ocean. Right. So it's not just like you take it all out and then the salt gets like dumped in a pile somewhere. Like they desalinate and then there's a really salt rich brine. So it's like, I don't know, 10 times, 20 times, something like that, way more salty than it came in, goes back into the ocean. And that's really not good for the local ecosystem. And they don't really know what the long-term effects of that might be. So when you think of California and having all their regulations, they're pretty cautious about doing stuff like that. I couldn't imagine California, as environmentally friendly as they are, pumping all this extra salty water back into their. Of course, the Pacific Ocean is not salt water, so.
Well, yeah. Well, yeah. It's
well. Is it salt water?
All oceans are salt water.
I'm exposed. Okay, all right. I thought I was exposing my lack of knowledge here, but yeah, that could be problematic.
It can, and if you think about where the intellectual population is. I mean, in terms of like engineering power sits today and has set for the last 20 odd years, it's in California. And there's engineers and scientific people from around the world have come to the Silicon Valley area and up and down California, for that matter, to create these software companies, these computer companies, these car companies, Tesla, in California. So you've got this intellectual powerhouse, and then the university system is really good in California. So you have brain power in that state to solve that problem. But there's been no incentive to do it. It isn't like the state's going to put $10 million into something like that. To my knowledge, they really haven't, because you don't see anything happening. You don't see any sort of Silicon Valley investors investing in desalination. So why? What is up with that? And it's almost like the Elon Musk thing lately, where they're talking about pulling CO2 out of the air, right? That they're the engineers and the scientific people are basically saying, we're never going to get there, so we need to suck CO2 out of the air. We're not going to do it by reducing emissions right now. That's an engineering approach, and they're putting money behind it. And maybe it's the right answer. Maybe it is the right answer. But you think desalination also be on that list because it's such a more immediate problem for California?
Yeah, it's complicated. Well, speaking of the ocean, let's talk quickly about the Beyond project, which is a Norwegian offshore wind to hydrogen project. That's BEHYOND. We've talked about these hybrid approaches before. This one's starting to get a little further along. Do you see this being a consistent thing in the future? Is creating hydrogen offshore really that important? Really that? Do you see it's going to be viable in the future?
It's energy intensive. I think that's the question about it. It's really energy intensive to make green hydrogen, essentially. Electrolysis, breaking water down into hydrogen. So it takes a lot of power, and then it takes power to transport the hydrogen to wherever it needs to be used in a truck, or my guess is trucks and airplanes are probably or maybe even industrial uses, furnaces, that kind of thing. If you have a surplus of energy, then hydrogen is very viable. If your cost of creating it is so low, like you're running a nuclear power plant and it's going to run at nighttime regardless, and there's just very little demand at nighttime, then it makes a lot of sense. But if you're having to go build something new, that cost gets tossed into the cost of the hydrogen production. Is it worth it? Probably not. I think the economics are not viable today. That doesn't mean we shouldn't be trying to look at it and see how we can make it better, or at least start to see those little seeds you need for any engineering project to get it going. But long term, it has a lot of struggles, because how much money are you going to throw at it before you say that's enough? That's a great question. How much benefit does it provide versus the cost which it is to produce? And we really haven't had that discussion at all. Isn't that weird, Dan? And everything else, we have a discussion about how much it costs to manufacture something or produce oil or whatever, pick it. But in hydrogen, it's we're going to go do this hydrogen thing, and costs don't get into that equation very much. And that's a struggle, I think, because eventually the costs are going to get big enough that somebody's going to ask, how much is it costing us to do this? There's only so much money in the country. How do we manage this? And is it a viable investment? I think right now, based on the level of activity you see around the world, the answer is not much viability yet.
So moving on to more prototypes. So this is an interesting one. The PowerPod wind turbine is it's a Salt Lake City, Utah based company called Halcium is behind it. And it's about the size of a barrel, like a whiskey barrel, beer barrel, whatever you want to call it. And their prototype is a intense lime green, and basically funnels air into it and then sort of increases the speed of the air to turn an internal turbine. So they said this increases the wind speed by 40%, and this little 1 kilowatt turbine is actually a pretty high power output comparatively to the full scale wind turbines. Alan, What's the engineering behind this? You're pretty savvy when it comes to jet engines and all this sort of stuff. This sort of has a similar look to it. Like if you imagine like a vertical jet engine. I'm not saying it's a jet engine, but what's the engineering here? Does this seem like a viable prototype for the future that someone would want to put in their backyard or bolt to the roof of their house?
It doesn't seem like it produces enough energy to be worthwhile yet. And I think maybe that's just because it's on a smaller scale. But essentially, they're directing air into a rotor that turns a generator. It creates power. That's essentially it. So you're pushing air into this funnel, and then it spins a disc, and that creates power. Not anything super complicated. From the outside, there's no moving parts, which I think is probably the engineering thrust behind it, in a sense, like with generating a standard vertical wind turbine or horizontal wind turbine. You got this rotating thing out in the open, and there's some risk associated with that. Instead of, you basically have this barrel thing with all the components internally. You can't necessarily get hurt with it, but it's also going to be very limited on how much energy it can produce, because you're really not where the wind is great. You're closer to the ground where the wind is not very good. As we have seen in all the wind turbine exercises, higher is better, offshore is better, near the ground is bad. So you're really limited on what it's going to be able to produce. Now, maybe there's some parts of the country, the world, in which there's always wind near the surface. That would make sense. Or if you're going to stall it up in the air, like on a roof or something, maybe it may provide some power. But is it really enough is it enough power for the cost of it that it makes sense? Is it cheaper than solar? I doubt it. Solar is really cheap right now. It's hard to compete with that. Wind's having a hard time competing with solar because of the flood of solar panels from overseas. But there's not always one solution to every power problem, and so you're going to need a variety of solutions based on what's going on. And different forms of energy like this one may satisfy some need. I mean, maybe there's a marketplace for it. Maybe there's a marketplace, if you're working off-site, you need a generator for some reason, for a pump or whatever. Maybe this is the right answer. So, it gets down to the economics of it. All businesses revolve around economics. And if the economics aren't there, then it won't survive. If the economics are good and there's a business case for it, it will survive. So it's sort of the capitalistic way of looking at it, but that's the reality of it. If we check on it on a year and they're still around, then maybe their business model made sense. If they're gone in a year, then probably didn't. Try something else.
Yeah, the idea that it could be significantly cheaper than solar, that seems like they're certainly going to obviously have to back that up, but that seems like that's hard to do. Solar's, like you said, solar's very cheap. And then just go in like, hey, we're way cheaper than them. That's definitely like a show me right. kind of statement,
right.
Because they're crowdfunding. If you go to their website, halcium.com, they're actively looking for investors, and this thing is, I would say, not super attractive to put in your backyard. The aesthetics are similar to like an air conditioner, like your the backdoor unit, the HVAC system. But, I don't know. We'll see. I mean, solar can be tucked out of the way. It can be thrown on your roof.
Right. Bingo. I think that's it.
Forget about it. That kind of thing is tough to come back from.
I think that's the key to all this, is where you're going to put it.
So let's talk a little bit about, in the news cycle, if you look at it right now, there's tons of stories about China deploys their first offshore floating wind turbine, or this country has their first floating wind turbine. This country has their first floating wind turbine prototype. So there's lots of prototypes getting out there. Floating wind is obviously going to be a big thing going forward. But there's lots of engineering problems that are still yet to be discovered with many of these models. Some will work better than others. Some might run into big problems that, again, we're just not going to be aware of. And Alan, you said you were pretty locked into this company, the Ocean Cleanup, and their work trying to clean up the Great Pacific Garbage Patch. And amongst all the waterways they can clean up. And their first system, the 1.0, had a lot of backing, a lot of engineers behind it. and it sounds like it really fell flat, and now they're sort of pivoting. So what was your takeaway from the ocean cleanup? It sounds like that there could be really big learning curves ahead, even for things that seem really well engineered and well thought out.
Yes. Everybody go back and go on YouTube or whatever your video channels are and look for the ocean cleanup about 2 years ago. And their introduction of, maybe it's 3 years ago now, their introduction of their system to collect plastic bits out in the Pacific Ocean, because they had put in numerous hours of research and study at universities and water tanks to simulate the ocean environment, and had eventually got enough funding and a lot of backing to create this system to haul out into the ocean and start collecting plastics. They thought they had it pretty much figured out. Like, it felt like they had the 90 percentile case figured out. So it may not be 100% effective, but it's going to be at least 90, and that's good enough, because we need to get that plastic out of that region as much as we can. Great concept, great. Ton of engineering work and a lot of really bright people working on this simultaneously. Felt positive. They take the first unit out to the ocean. They have a lot of problems. It breaks apart. Part of it breaks off, starts floating away. It's not collecting the plastic they think it's going to collect. They sort of regroup in Hawaii and make some mods to it. Still not what they expected. Created some smaller collection systems just on the fly, just basically cheap and dirty. Let's see what the physics are. Let's get the first principles here. Let's see what's going on. And everything they tried, some of them worked, some of them didn't work, but it's a question of how well that they were, how much plastic did it attract versus how much it would cost to operate this floating system. And that's where the struggle lies, is that they realized that the cost per kilogram of or pound of plastic brought out of the ocean was going to be very high for this self-floating system, and it wasn't very effective. So they got to this new system, which they introduced, I think it was yesterday, or within the last 48 hours. And there's a really interesting hour-long presentation on YouTube talking about it, but essentially they've really changed the whole design. So instead of a free-floating system, they have a couple of boats and a U-shaped piece of tubing that they're dragging behind it to collect the plastic into this, to catch the plastic. Completely different model. And it gets to sort of the engineering, Dan. If you think you know everything, and then you go to the ocean, and it just doesn't work, because there's a lot of variables in the ocean which don't exist in the lab. And it's really hard to predict what happens over a year span in the ocean. And we just don't know that much about it. And I think the same case exists for wind in the ocean. We're going to learn the hard way, just like ocean cleanup did, on what the difficulties are going to be. And don't you just see that? Because the ocean is such a treacherous place for any engineering project.
Yeah, and I don't know how you simulate that in the lab, because unless you're putting it in an area where it's always calm, which obviously the ocean never is, right? So now you have different levels of choppiness each day, different wave height out there.
Currents are different.
Just different currents. Things are swirling.
Right.
There's mischievous dolphins stealing, your equipment. The Loch Ness Monster, the Kraken, they're all lurking somewhere beneath. But no, yeah, it just seems the ocean it just seems super unpredictable. And that, like you said, it seems like that's one of the things that we have the least lockdown of our understanding of how it works. Just like Think
about anything that has been engineered to be in the ocean. How long has it lasted? Like, is there a 1,000-year piece of engineering out in the ocean? No, but there's 1,000-year structures on land. Well, the pyramids in Egypt.
Stonehenge is still kicking.
Right, yeah. Right. Or you're like, oh, on land, yeah, we kind of got that figured out. We know what the environment is. We can make something that'll last thousands and thousands of years. But in the water, the ocean is pretty good about killing engineering projects. And we have yet to really conquer it. The salt's a big problem, the winds, the lightning, the animals, the whole thing, and the fungus, all the growing plants. I mean, there's going to be something that's going to try to take down whatever you stick in the ocean. And I just, my gut engineering says, we're at that 90 percentile case, like kind of like the ocean cleanup is right now. We kind of have a pretty good handle on what we think is going to happen, but we're going to learn the hard way. And the question in my mind is, do you massively push out offshore wind within, let's just say it's 5 years. So you like just flood the market and flood the ocean with a bunch of wind turbines. Or do you start getting some out there now and you stage it? I learned from the previous ones and then I get better and better. And maybe I can make something that lasts in the ocean 20, 30 years left by itself, ideally. But maybe I can't, and it's just in the record of humans versus the ocean has wins most of those events, and that's what scares me about it.
Yeah, well, there's a lot of different prototypes for offshore wind, all the different floating things, and until there's hurricanes that roll through them, until there's, I don't know, a tsunami that rolls through, like right. There's going to be a lot of learning moments, and I'm sure everyone knows that, sure. Right? And that'll be really interesting just to see how it all plays out, because there will be some public failures, which weren't from bad engineering. They were just like black swan events that, no one really could have foreseen this. We just didn't understand. Yeah. And here we are, but we're learning.
Yeah, and I think from the engineering standpoint, if you're talking about an engineer sitting at their desk designing a system, the first thing that happens, and then which they need to happen as a touch point, is where do I box this problem? At what level do I say it needs to handle X? This wind, this waves, this current, boom, 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 boom. Okay, so I frame the problem. And then all the engineers get really happy because I got a frame. And once I have a frame, I can build inside of that frame. Awesome. The problem is if the frame is off, if the frame is slightly off, no matter how well you design it within that box, that box isn't the right framework for where you're going to put the turbine. And I think that's the trouble. I think there's a lot of confidence. I think you get a lot of, I don't want to say false confidence, but you get that kind of false confidence that, we're going to be able to, this thing's going to be perfect, but you're only working inside this box of constraints. If the ocean throws you something outside of that, then you're in trouble. And that's where we're going to learn the hard way. It's inevitable.
All right, well, that's going to do it for this week's episode of the Uptime Podcast. Thanks so much for listening. Be sure to subscribe to the show, leave us a review. We'd greatly appreciate it, and share with a friend who maybe hasn't heard of us yet. Also, be sure to check out the description or show notes below where you can sign up for Uptime Tech News, our weekly update on the show, so you can be alerted when our next podcast episode drops. Thanks again, and we will see you here next week on the Uptime Wind Energy Podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.